The Marine sergeant ran his hand along the turret face of the captured Japanese tank, then stopped. His fingers found the hole. It was clean, perfectly circular, roughly the diameter of a pencil. He traced the edge, feeling where the metal had been punched inward, then walked around to the other side of the turret. There was the exit wound, slightly larger, the steel peeled outward like the petals of a crude flower. "Sir, you need to see this," he called to the lieutenant examining the tank's engine compartment. It was July 23rd, 1944, on Tinian Island in the Marianas. The Type 97 Chiha medium tank sat motionless in a clearing near the beach, one of several Japanese armoured vehicles captured intact after the island's defenders had withdrawn or been killed. This particular tank had been abandoned by its crew, engine still functional, ammunition still loaded in its racks. It bore multiple impact marks across its hull and turret, but what had drawn the sergeant's attention was different from the obvious damage caused by bazooka rounds and anti-tank guns. The Marine Ordnance team had been conducting what they called a destructive analysis, a systematic examination of captured enemy equipment to understand its capabilities and vulnerabilities. They had started with measurements, carefully documenting the tank's dimensions and armour thickness at multiple points. The turret face, they had confirmed with calipers, was 25 millimeters thick. That was substantial, nearly an inch, more than double the thickness of the Type 95 Hargo light tanks that Marines had encountered on Saipan the previous month. 25 millimeters should have provided protection against rifle fire and light machine guns. Japanese engineers had designed it that way. The Chiha was supposed to be Japan's answer to modern armoured warfare, a medium tank capable of standing against enemy armour and supporting infantry assaults against fortified positions. It was heavier than the Hargo, better armed, better protected. But the sergeant was staring at a hole that shouldn't exist. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The lieutenant came around from the rear of the tank, wiping diesel fuel from his hands with a rag. He was a veteran of Guadalcanal and Cape Gloucester, experienced enough to have seen Japanese tanks in combat before, though never this close, never with the opportunity to examine one at leisure. He looked at the hole the sergeant was indicating, then at the corresponding exit hole on the far side. 30 caliber, the sergeant said. Has to be. Diameter's right, and look at the impact pattern. Not a 50 cal, those leave bigger holes. Not a 37 millimeter. Trajectory's wrong. This is a rifle caliber round, went straight through the turret face. The lieutenant pulled out his measuring tape and confirmed the armour thickness himself. 25 millimeters, just as the specifications indicated, just as Japanese military planning had intended. He examined the hole more closely, noting how the edges showed no sign of spalling or shattering, just clean penetration. The round had gone through as if the armour were tin. Other Marines gathered around as word spread. Men who had been checking the tank's ammunition load or examining its suspension system came to look. They had all received training on Japanese armour capabilities. They had been told the Chiha was a serious threat, more dangerous than the light tanks they had encountered previously. Intelligence reports described it as Japan's primary medium tank, combat-proven in China, deployed throughout the Pacific. Yet here was evidence that even this supposedly improved armour could be defeated by standard infantry weapons under the right conditions. The question that hung in the humid Tinian air, unspoken but present in every man's mind, was simple and profound. If a 30 caliber round could penetrate what was supposed to be the Chiha's strongest armour, what did that mean about everything they had been told regarding Japanese armoured warfare capability? The Type 97 Chiha was not supposed to be vulnerable. Its development had been deliberate, carefully planned, based on lessons Japan had learned from nearly a decade of armoured warfare experience. When Japanese military planners gathered in Tokyo in 1936 to discuss specifications for a new medium tank, they believed they understood modern armour requirements. They were wrong, but their confidence was not baseless. The Imperial Japanese Army had been operating tanks since the 1920s. They had purchased foreign designs, studied European and American developments, and built an indigenous tank industry. By the mid-1930s, Japanese forces in Manchuria and China were using armor effectively against opponents who had limited means to encounter it. The Type 89 medium tank and the Type 95 Ha-Go light tank had proven themselves in these campaigns, providing mobile firepower that Chinese forces struggled to defeat. But Japanese military observers recognized limitations. The Type 89 was slow, barely capable of 15 miles per hour, making it suitable only for direct infantry support at walking pace. The Ha-Go was faster and more mobile, but carried only a 37mm gun and had armor that could be penetrated by heavy machine guns at close range, as events at Saipan would later prove. Japan needed something in between, a tank that combined mobility with better protection and heavier armament. The Army Technical Bureau issued requirements in 1936. The new medium tank would weigh approximately 15 tons, making it heavy enough to carry substantial armor, but light enough for Japan's limited industrial capacity to produce in meaningful numbers. It would mount a 57mm gun, providing better anti-tank capability than the Ha-Go's 37mm weapon. It would have armor thick enough to resist standard anti-tank rifles, the primary anti-armor weapon most armies possessed in the mid-1930s. Mitsubishi Heavy Industries received the contract. The same company that had designed the Ha-Go took on the challenge of creating Japan's new medium tank. Engineer Tomio Hara, who had established his reputation with earlier designs, led the development team. They faced constraints that American or German tank designers did not encounter. Japan's steel production was limited. The nation's industrial base, while growing, could not match Western manufacturing capacity. Every kilogram of armor added to the design meant fewer tanks could be produced, fewer resources available for other military programs. Hara and his team made calculated compromises. The Chi-Ha would have 25mm of armor on the turret front and upper hull, tapering to 20mm on the sides, and as thin as 12mm on the rear deck and floor. This was thicker than the Ha-Go, but still modest by international standards. For comparison, the Soviet T-34, entering service at roughly the same time, carried 45mm of sloped frontal armor. The American M3 Lee medium tank, developed shortly after, had 51mm on the hull front. Japanese engineers justified these figures through careful calculation. 25mm of steel could stop rifle bullets at any range. It could resist standard machine gun fire. It could defeat the anti-tank rifles that China and other potential opponents possessed. Most importantly, it was thick enough to manufacture in quantity using Japan's available industrial resources. The Chi-Ha's 57mm Type 97 gun was a significant upgrade from the Ha-Go's armament. It fired a shell weighing approximately 5.5 pounds at a muzzle velocity of 1,100 feet per second. Against soft targets, bunkers, and fortifications, it was effective. Against enemy armor, Japanese testing showed it could penetrate approximately 50mm of vertical plate at 500 meters. This was adequate against most tanks Japan expected to face in China and Southeast Asia. The tank's crew consisted of 4 men. The driver sat in the front left of the hull machine gunner to his right operating a Type 97 7.7mm machine gun. The turret housed the commander and gunner, working in a space that was cramped but less impossible than the single-man turret of the Ha-Go. The commander could focus on commanding while the gunner operated the main weapon, a significant improvement in crew efficiency. Japan's approach to armored warfare was shaped by geography, resources, and experience. Unlike Germany, which developed tank doctrine based on mobile warfare across the open terrain of Central Europe, or the Soviet Union, which prepared for massive mechanized battles on the steppes, Japan designed its armor for a different kind of war. The tanks would operate in Manchuria, in China, in the jungles and islands of Southeast Asia and the Pacific. They would face opponents with limited industrial capacity and minimal armor of their own. This strategic context shaped every aspect of Chi-Ha design. The tank's ground pressure was kept low, allowing it to traverse soft ground and rice paddies without bogging down. Its suspension system, using bell crank bogies similar to the Hargo, provided adequate cross-country mobility. The Mitsubishi Type 97 air-cooled diesel engine, producing 170 horsepower, gave the tank a road speed of 24 miles per hour and a cross-country speed of approximately 15 miles per hour. This was not exceptional by international standards, but it was adequate for supporting infantry operations in the terrain where Japan expected to fight. The Chiha entered service in 1938 and almost immediately proved itself in combat. In China, where Japanese forces faced an opponent with virtually no armor and limited anti-tank weapons, the tank performed exactly as designed. Its 57mm gun destroyed fortifications and suppressed infantry positions. Its armor protected the crew from rifle and machine gun fire. Its mobility allowed it to exploit breakthroughs and support rapid advances. Japanese tank crews gained confidence from these successes. Officers reported that the Chiha met or exceeded expectations. Maintenance personnel found it reliable and relatively simple to repair in field conditions. The diesel engine, in particular, was praised for its fuel efficiency and reduced fire risk compared to gasoline-powered vehicles. Production ramped up at Mitsubishi facilities, with additional manufacturing at other plants as demand increased. By 1941, when Japan initiated war across the Pacific, the Chiha represented the backbone of Japanese armored forces. Tank regiments deployed to Malaya, the Philippines, and the Dutch East Indies were equipped primarily with Chiha medium tanks and Hargo light tanks. Japanese military planning assumed these forces would face British, American, and Dutch colonial troops who had limited armor support and whose doctrine emphasized infantry and artillery rather than mechanized warfare. This assumption proved correct in the early campaigns. In Malaya, Chiha tanks navigated terrain. British commanders thought impassable for armor, supporting the rapid Japanese advance down the peninsula. In the Philippines, Chiha tanks engaged American forces that had minimal armor support and were still organizing their defenses. In the Dutch East Indies, Japanese armor encountered no serious opposition at all. These victories reinforced Japanese confidence in their tank designs and doctrine. From the perspective of commanders and crews in 1941 and 1942, the Chiha was a successful medium tank. It had proven itself in combat across diverse terrain and against multiple opponents. It was reliable, maintainable, and effective in its intended role. Production continued, and by 1943, over 1,100 Chiha tanks had been manufactured, making it Japan's most numerous medium tank. But the war was changing in ways Japanese planners had not anticipated. The rapid victories of 1941 and early 1942 gave way to grinding attrition. American forces, initially caught off guard and fighting defensive battles with inadequate equipment, were being reinforced with new weapons, better armor, and overwhelming quantities of supplies. The industrial disparity that would doom Japan's war effort was beginning to manifest on Pacific battlefields. When Marines landed on Saipan in June 1944, they brought with them not just numerical superiority, but technological advantages that Japanese defenders could not match. Among the equipment the Marines possessed were weapons that would fundamentally challenge everything Japanese tank crews believed about their armor's protective capability. The Chiha, designed to resist the weapons of China's armies in the 1930s, was about to face the firepower of America's industrial military in the 1940s. The gap between these two realities would be measured in millimeters of steel and in the lives of men who discovered, too late, that what they trusted to protect them could not. The systematic examination of captured Japanese equipment was not casual curiosity. By mid-1944, the United States Marine Corps had established formal protocols for evaluating enemy materiel, protocols born from hard-earned experience in earlier campaigns where inadequate intelligence about Japanese capabilities had cost American lives. The Ordnance teams tasked with examining captured Chiha tanks on Tinian operated under specific directives from Fleet Marine Force Pacific Headquarters, directives that emphasized thorough documentation and practical testing. Lieutenant Robert Chen, the Ordnance officer overseeing the Tinian examination, had received his training at the Army Ordnance School at Aberdeen Proving Ground in Maryland before being assigned to the Pacific Theatre. He understood metallurgy, armor penetration mechanics, and the systematic methodology required for reliable testing. His team included an armor specialist who had worked in civilian life as a metallurgical engineer for Bethlehem Steel, 2 experienced armorers who maintained the division's weapons, and several Marines with mechanical aptitude who could disassemble and analyze complex machinery. Their first task was measurement. Using precision calipers and gauges, they documented the Chiha's armor thickness at multiple points. The turret face measured 25 mm consistently across its surface. The turret sides were 25 mm as well, maintaining uniform protection around the crew compartment. The hull front measured 25 mm on the upper glacis, the angled plate that formed the tank's front face. Side armor measured 20 mm, slightly thinner but still substantial. The rear hull and engine deck, less critical areas that enemy fire was less likely to strike, measured between 12 and 20 mm depending on location. These measurements were recorded in official reports, photographed for documentation, and compared against intelligence estimates that had been compiled from earlier encounters and from technical manuals captured in previous operations. The figures matched what Japanese specifications indicated. There were no surprises in the basic armor layout. The Chiha was built as designed, with no significant deviations from its engineering blueprints. The team then examined the armor quality itself. Using a hardness tester, they checked the steel's surface properties at various points. The results indicated face-hardened armor, a manufacturing process where the outer surface of the steel plate is hardened through heat treatment, while the interior core remains tougher and more resistant to cracking. This was sound metallurgical practice, used by most nations producing armored vehicles. Face hardening caused small-caliber projectiles to shatter against the hard outer surface rather than penetrating, while the tough inner core prevented the armor from cracking under impact. The armor's chemical composition, analyzed later through laboratory testing of samples, revealed steel with carbon content appropriate for armor plate, but with lower alloy content than American or German armor steel. Japan's limited access to certain alloying metals, particularly nickel and molybdenum, meant their armor steel was not as strong per unit thickness as Western equivalents. This was a subtle disadvantage, not immediately obvious from visual inspection, but significant in terms of actual protective capability. Next came the functional assessment. The team operated the Chiha's systems, testing its engine, transmission, turret traverse mechanism, and weapons. The Mitsubishi diesel engine started readily and ran smoothly, confirming Japanese reputation for reliable power plants. The transmission shifted cleanly through its 4 forward gears. The turret rotated via hand crank, requiring significant physical effort, but functioning as designed. The 57mm gun's breech mechanism operated correctly, and the elevation and traverse controls responded precisely. The hull machine gun, a Type 97 7.7mm weapon, was removed and test-fired. Its mechanism was simple, reliable, and showed good engineering. The optical sights for both the main gun and the machine gun were examined and found to be adequate, though not as sophisticated as American equivalents. The radio equipment present in the particular tank was tested and found functional, though its range was limited compared to American sets. What struck Lieutenant Chen most forcefully during this examination was not any single deficiency, but rather the cumulative evidence of resource constraints. Every system worked, every component functioned as designed, but everything was built to a standard of economy rather than excellence. The armor was adequate, but not exceptional. The engine was reliable, but not powerful. The weapons were effective but not superior. The entire vehicle represented careful optimization for limited industrial capacity rather than the pursuit of technical superiority. This philosophy extended to crew accommodations. The interior space, while better than the Hago's cramped fighting compartment, was still minimal by American standards. The commander and gunner in the turret had barely enough room to perform their duties effectively. Ammunition storage consisted of racks that held shells loosely, rather than in protective containers. Vision equipment was crude, with small periscopes and limited direct vision ports. There was no turret basket, forcing crew members to stand on the hull floor, and no seats for the turret crew, meaning they remained standing throughout operations. The marine engineers documented everything methodically, filling notebooks with measurements, observations, and technical sketches. They photographed the tank from every angle, both exterior and interior. They created detailed diagrams showing armor thickness, component layout, and crew positions. This documentation would be compiled into reports sent to higher headquarters, where it would inform tactical doctrine and training for Marines who would encounter Chiha tanks in future operations. But the most significant discovery came not from measurements or mechanical testing. It came from examining the battle damage the tank had sustained before its capture. The captured Chiha on Tinian bore evidence of the battle that had disabled it. Multiple impact marks scarred its hull and turret, each telling a story of the engagement that had forced its crew to abandon the vehicle. Some impacts were immediately identifiable. A large crater on the rear hull, surrounded by blast scoring, marked where a bazooka round had struck. The 2.36-inch rocket had penetrated completely, its shaped charge warhead burning through the thin rear armor and destroying internal components. This was expected, anticipated. Bazookas were designed specifically for defeating armor. Another obvious impact showed where a 37mm anti-tank gun had struck the turret side at an angle. The round had not penetrated but had created a deep gouge in the armor, demonstrating that even the M3 anti-tank gun, a relatively light weapon by 1944 standards, could damage the Chiha under favorable conditions. Again, this was unsurprising. Anti-tank guns were supposed to defeat tanks, but scattered across the tank's hull and turret were dozens of smaller impacts, and these demanded explanation. They were circular marks, some showing clean penetration completely through the armor, others showing partial penetration where rounds had struck at oblique angles and deflected. The sergeant who had first noticed these marks during the initial inspection had been correct in his assessment. These were rifle-caliber impacts, far too small to be anti-tank weapons, far too numerous to be coincidental. Lieutenant Chen ordered a systematic examination of every suspicious impact mark. His team used calipers to measure hole diameters, examined impact angles, and attempted to determine what type of ammunition had created each penetration. The results were documented with photographs showing measuring tools placed against the holes for scale, with detailed notes recording location, diameter, and characteristics of each impact. The conclusions were unavoidable. Multiple penetrations showed characteristics consistent with 30 caliber armor-piercing ammunition fired from standard infantry rifles or machine guns. The diameter matched 30.06 M2 armor-piercing rounds. The penetration depth and angle matched what would be expected from such rounds, striking steel plate of this thickness at close to moderate range. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. To verify their findings, Lieutenant Chen arranged for controlled testing. With permission from division headquarters, his team would conduct live-fire tests against another captured Chiha that had been recovered with severe mechanical damage, making it unsuitable for further examination of its systems, but perfect for destructive testing. The tank was positioned at a test range near the beach, with armor plates marked to indicate thickness at various points. Firing positions were established at ranges of 50 meters, 100 meters, and 200 meters. Marine riflemen using standard M1 Garand rifles loaded with M2 armor-piercing ammunition fired at the marked points on the turret and hull. At 50 meters, firing at the turret face where armor measured 25 millimeters, 3 rounds out of 10 penetrated completely. At 100 meters, 1 round out of 10 penetrated. At 200 meters, none penetrated the turret face, though all left visible impact craters in the armor. The side armor, measuring 20 millimeters, showed higher penetration rates. At 50 meters, 6 rounds out of 10 penetrated. At 100 meters, 4 rounds out of 10 penetrated. At 200 meters, 1 round out of 10 penetrated, though others came very close, creating deep craters that weakened the armor significantly. The rear deck armor, measuring 12 millimeters in most places, was even more vulnerable. At all tested ranges, standard 30 caliber armor-piercing rounds penetrated consistently. This was the same thickness as the Hargo's maximum armor, and it proved equally inadequate against rifle fire. But the most shocking results came from testing with the Browning M1900 and 1930 caliber machine gun, the standard medium machine gun used by Marine infantry squads. When fired in sustained bursts at close range, the concentration of impacts against the Chaiha's armor produced catastrophic effects. Rounds that individually might not penetrate began to work the armor, creating stress fractures and weak points. Follow-up rounds, striking near previous impacts, had higher penetration rates. Within a single sustained burst of 20 to 30 rounds, machine gunners could create multiple penetrations in the turret face at ranges under 100 meters. The Ordnance team documented everything with clinical precision. Each test was photographed. Each penetration was measured and recorded. The data was compiled into tables, showing penetration percentages at various ranges against different armor thicknesses. The conclusions were typed into formal reports, with copies forwarded to Fleet Marine Force Pacific, to Marine Corps headquarters in Washington, and eventually to the Army Ordnance Department at Aberdeen Proving Ground. The technical findings were clear, but Lieutenant Chen understood their implications extended far beyond ballistics and metallurgy. He had examined the interior of the Chaiha before testing began. He had seen the cramped crew compartment, the absence of protective features, the way ammunition was stored loosely throughout the fighting space. He understood what it meant for rifle-caliber rounds to penetrate that interior. A single 30 caliber armor-piercing round entering the crew compartment could strike the commander, the gunner, the ammunition racks, or the engine components visible through the fighting compartment. Multiple penetrations from machine gun fire meant multiple rounds ricocheting inside the confined space, striking everything and everyone. There would be nowhere to hide, no protection, no chance of survival if the armor failed. The Marines who witnessed the live fire testing or examined the documented results experienced a fundamental shift in their understanding of Japanese armor capability. Men who had received training emphasizing caution when engaging enemy tanks, who had been instructed to call for dedicated anti-tank support when armor was encountered, now possessed knowledge that changed everything. The Type 97 Chaiha, Japan's primary medium tank, could be engaged effectively with standard infantry weapons under the right conditions. Corporal James Mitchell, a squad leader in the 2nd Marine Division who had fought on Saipan and was now preparing for operations on Tinian, attended a briefing where the test results were presented. He later recorded his thoughts in letters home that survived the war. We were shown photographs of the Jap medium tank, with holes punched through by regular rifle bullets, he wrote. The lieutenant explained that at close range, our armor-piercing ammo could go straight through what the Japs considered adequate protection. It changed how we thought about their armor. They weren't invincible. They weren't even particularly dangerous if you knew what you were facing. This sentiment spread through Marine infantry units as word of the testing circulated. The psychological barrier that armor creates, the instinctive fear of facing a protected mobile gun platform, began to dissolve. Marines had already learned from Saipan that 50 caliber machine guns could defeat Japanese light tanks. Now they understood that even the heavier Chaiha could be vulnerable to weapons every infantryman carried. Tactical doctrine evolved rapidly to incorporate these findings. Squad leaders were instructed that when encountering Japanese armor, they should employ all available weapons rather than immediately withdrawing or calling for dedicated anti-tank support. Riflemen with armor-piercing ammunition should engage the tank's sides and rear, aiming for penetration of the thinner armor. Machine gunners should concentrate fire on turret faces and hull sides, creating multiple impacts that increased the probability of penetration. Bazookas and anti-tank guns remained the preferred weapons for engaging armor, but their absence no longer meant helplessness. The confidence this knowledge provided was profound. Marines preparing for the invasion of Peleliu in September 1944 received briefings that included information about Chiha vulnerabilities. Those planning for Iwo Jima and Okinawa in early 1945 knew that Japanese armor, while still dangerous, was not the formidable threat it might appear to be. The psychological advantage shifted decisively to American forces. For Japanese tank crews, had they known what American testing had revealed, the knowledge would have been devastating. They climbed into their Chiha tanks, believing the armor would protect them from rifle and machine gun fire. This was fundamental to armored warfare doctrine, the basic premise that allowed tank crews to function in combat. The armor kept you alive while you engaged the enemy with superior firepower. Without that protection, a tank became a metal coffin, confining the crew while offering no meaningful safety. Japanese tankers on islands throughout the Pacific continued fighting with Chiha tanks through the remainder of the war. But the strategic situation made their efforts increasingly futile. On Peleliu, Marines encountered Chiha tanks used as stationary pillboxes, dug into prepared positions rather than employed in mobile operations. This defensive use reflected Japanese recognition that mobile armor warfare against American forces was suicidal, but it also meant the tanks were reduced to stationary targets that could be systematically destroyed by infantry weapons, artillery, and airstrikes. On Iwo Jima, Japanese forces had virtually no armor, recognizing that the island's terrain and the expected intensity of American firepower made tank operations impossible. The tanks that might have been sent to Iwo Jima were held back for the defense of Okinawa and the Japanese home islands, where commanders hoped they might serve some useful purpose in delaying the inevitable American advance. On Okinawa, the 27th Tank Regiment, equipped with Chiha and Ha-Go tanks, attempted mobile counterattacks during the early days of the American invasion in April 1945. The results replicated what had occurred at Saipan nearly a year earlier. American weapons, from bazookas to anti-tank guns to tank destroyers to Sherman tanks to ordinary infantry rifles with armor-piercing ammunition, destroyed Japanese armor quickly and decisively. Most of the regiment's tanks were eliminated within the first week of combat, their burning hulks littering Okinawan roads and fields. The Marines who destroyed these tanks felt no particular triumph. By late in the war, engaging Japanese armor had become routine, almost mundane. The fear and respect that armor typically commanded in military operations had evaporated, replaced by clinical efficiency. Japanese tanks were targets to be destroyed, obstacles to be cleared, not serious threats requiring special measures or causing significant concern. Lieutenant Chen's reports from the Tinian testing eventually reached analysts at Marine Corps headquarters and at the Army's intelligence services. They were compiled with similar reports from other testing conducted on captured equipment throughout the Pacific. The accumulated evidence painted a comprehensive picture of Japanese armor capabilities and vulnerabilities, a picture that informed American tactical doctrine and strategic planning for the remainder of the war. But beyond the tactical and operational implications, the testing revealed something more fundamental about the nature of the Pacific War. The disparity between Japanese and American military capability was not simply numerical, though American advantages in production and resources were overwhelming. It was qualitative, reflecting differences in industrial capacity, materials science, design philosophy, and the accumulation of small technical advantages that together created an unbridgeable gap. The Chiha tank, carefully designed by competent engineers working within severe constraints, represented what Japan could produce, given its industrial base and resource limitations. It was not a bad tank by the standards of the mid-1930s. Against the opponents Japan had faced in China, it had performed adequately, but by 1944, it was facing an opponent whose industrial capacity allowed not just the production of more equipment, but the production of fundamentally better equipment designed without the severe constraints that limited Japanese engineers. The reports from Lieutenant Chen's Ordnance team on Tinian reached Marine Corps headquarters in Washington by late August 1944. They arrived alongside similar documentation from other captured equipment examinations conducted throughout the Pacific Theater, forming part of a comprehensive intelligence picture that was reshaping American understanding of Japanese military capabilities. The implications were immediately incorporated into training materials and tactical doctrine for units preparing for future operations. The Marine Corps schools at Quantico, Virginia, revised their instruction on encountering Japanese armor. Previously, training emphasized the threat posed by enemy tanks and the importance of employing dedicated anti-tank weapons. The new guidance, informed by testing data from Tinian and combat reports from Saipan, provided a more nuanced assessment. Japanese light tanks were vulnerable to 50-caliber machine gun fire at close range. Japanese medium tanks, including the Chaiha, could be engaged effectively with armor-piercing rifle ammunition and concentrated machine gun fire under favorable conditions, particularly against side and rear armor. This information filtered down to replacement training battalions where new Marines prepared for deployment to the Pacific. Instructors demonstrated armor-piercing ammunition capabilities, sometimes using captured Japanese armor plates as training aids. Marines learned that while respect for enemy armor was appropriate, fear was not. They were taught to identify vulnerable points on Japanese tanks, to understand engagement ranges where infantry weapons became effective, and to maintain aggressive tactics rather than defensive postures when encountering enemy armor. The psychological shift this training created was significant. Marines arriving in the Pacific Theater in late 1944 and early 1945 possessed confidence their predecessors had lacked. They understood the technical realities of the weapons they carried and the armor they might face. This confidence translated into more aggressive combat behavior, faster decision-making in contact situations, and reduced casualties from encounters with Japanese armor. On Peleliu in September 1944, Marines encountered Chiha tanks used primarily as stationary defensive positions. The tanks had been dug into prepared emplacements, their mobility sacrificed for protection, their role reduced from mobile assault platforms to armored pillboxes. Even in this defensive posture, they proved vulnerable. Marine infantry approached with confidence, employing bazookas and rifle grenades against vision ports and exposed surfaces, using flamethrowers to force crews out, and calling on Sherman tanks to eliminate positions that proved particularly stubborn. The Japanese use of armor as static defenses rather than mobile forces reflected their own assessment of tactical realities. Tank commanders throughout the Pacific had witnessed what happened when Japanese armor attempted mobile operations against American firepower. At Saipan, 31 tanks had been destroyed in a single night engagement. On Guam, Japanese tank counterattacks had achieved nothing except the loss of nearly every armored vehicle committed. The lesson was clear to Japanese officers, if not always to higher headquarters, still clinging to doctrine developed for different circumstances against different opponents. By late 1944, Japanese tank units received orders that implicitly acknowledged their armor's inadequacy for mobile warfare. Tanks were to be dug in, used as pillboxes, employed only for local counterattacks against exposed American positions, and preserved as long as possible rather than committed to decisive engagement. These were the tactics of desperation, the admission that Japanese armor could not contest American forces in open battle. On Iwo Jima, in February 1945, Japanese defenders had no tanks at all. The island's garrison commander, Lieutenant General Tadamichi Kuribayashi, had studied American capabilities carefully and concluded that armor would be wasted in the type of defensive battle he intended to fight. Instead, Japanese forces fortified the volcanic rock with tunnels, bunkers, and interconnected defensive positions, designed to maximize casualties while accepting that defeat was inevitable. The absence of armor on Iwo Jima represented perhaps the clearest acknowledgement by Japanese commanders that their tanks could not meaningfully affect battle outcomes against American forces. On Okinawa in April 1945, the 27th Tank Regiment made one final attempt at mobile armored operations. On the night of May 4th, Japanese forces launched a major counteroffensive designed to push American forces back and disrupt their advance. The tank regiment committed its remaining Chiha and Hargo tanks in support of infantry assaults against Marine and Army positions. The attack failed completely. American artillery, pre-registered on likely approach routes, devastated the advancing formations. Sherman tanks, positioned in defensive positions, engaged Japanese armor at ranges where the Chiha's 57mm gun was ineffective, while American 75mm guns destroyed targets with impunity. Marine infantry, confident and well-trained, engaged Japanese tanks with bazookas, rifle grenades, and concentrated small arms fire. By dawn on May 5th, most of the regiment's tanks were burning wrecks, their crews dead, their contribution to the battle negligible. The survivors of these engagements, the Japanese tank crewmen who lived through encounters with American forces, carried knowledge that was both tactically useless and psychologically devastating. They knew their equipment was inadequate. They knew that climbing into a Chiha tank meant entering a vehicle that could not protect them against weapons American infantry carried as standard equipment. They knew that surviving combat depended more on American decisions about whether to destroy their tank immediately or bypass it temporarily than on their own skill or courage. Some captured Japanese tankers, interrogated by American intelligence officers, expressed this knowledge openly. Others maintained silence, the cultural imperative against admitting defeat or criticizing their nation's war effort, overriding even the relief of having survived. But the pattern in interrogation reports was consistent. Japanese tank crewmen had lost faith in their equipment, in their doctrine, and in their chances of survival. They fought because they were ordered to fight, because surrender was culturally unacceptable, because there was no alternative, not because they believed they could achieve victory or even significantly delay American advances. The vulnerability of the Chiha tank was not an engineering failure in the conventional sense. Japanese designers had created a vehicle that met the specifications they were given, using the resources available to them for the war they expected to fight. The tank's inadequacy in 1944 reflected not incompetence, but the impossibility of Japan's strategic situation, the fundamental mismatch between the nation's industrial capacity and the demands of modern mechanized warfare against a peer industrial power. Japan's entire tank production from 1935 through 1945 totaled approximately 4,000 vehicles of all types. This included light tanks like the Hargo, medium tanks like the Chiha, and smaller numbers of heavier designs that saw limited service. 4,000 tanks across a decade of war, deployed across China, Southeast Asia, the Pacific Islands, and eventually held back for homeland defense. The United States, by comparison, produced nearly 90,000 tanks during the war. Years. This figure included light tanks, medium tanks like the Sherman, and heavy tanks, but the majority were Shermans, produced in vast quantities at facilities across the American industrial heartland. The Detroit tank arsenal alone could produce more tanks in a single month than Japan produced in an entire year. The numerical disparity was approximately 20-1, a ratio that made strategic victory impossible regardless of tactical skill or individual courage. But the disparity was not merely numerical. American tanks were better protected, better armed, more reliable, and supported by a logistics system that ensured they remained operational. Sherman tanks had armor that Japanese anti-tank weapons struggled to penetrate. They had guns that could destroy any Japanese tank from ranges where Japanese weapons were ineffective. They had radios in every vehicle, enabling coordinated operations. They had mechanical reliability that came from sophisticated manufacturing and quality control. Japanese industry could not match this standard. The nation's steel production was limited, constrained by access to raw materials that American submarines were steadily reducing. Alloy metals necessary for high-quality armor steel were scarce. Manufacturing facilities lacked the sophisticated machine tools and production processes that American factories employed. Quality control was inconsistent, with individual tanks varying in performance and reliability. The Chiha's 25mm armor represented what Japanese industry could produce in quantity. Thicker armor would have required more steel per vehicle, reducing production numbers and straining an already overtaxed industrial base. Better quality armor steel would have required alloys Japan did not possess in sufficient quantities. The tank's designers chose 25mm because it was the maximum thickness they could apply while maintaining production rates their military required. This calculation made sense in the strategic context of 1937 when the Chai-Ha was designed. Japan's likely opponents were China, which had virtually no armor, and potentially the Soviet Union, whose armored forces in the Far East were equipped with older designs vulnerable to the Chai-Ha's 57mm gun. The British and Dutch colonial forces in Southeast Asia were not expected to have significant armor deployed. American forces in the Philippines were known to be limited in numbers and equipment. What Japanese planners failed to anticipate, or chose to ignore, was America's industrial mobilization potential. The United States in 1937 was still recovering from the Great Depression. Its military small and its industrial capacity focused on civilian production. But that civilian industrial base, those automotive factories and steel mills and machine tool manufacturers, represented latent military potential that could be activated when necessary. Pearl Harbor activated that potential. The attack unified American public opinion, enabled total mobilization of industrial resources, and initiated a production surge that Japanese planners had not believed possible. Factories converted from civilian to military production within months. New facilities were constructed specifically for war production. Women entered the workforce in unprecedented numbers, expanding available labor beyond what peacetime demographics would suggest. The result was industrial output that dwarfed Japanese capacity in every category. By 1944, American factories were producing one destroyer every week, one aircraft carrier every month, one merchant ship every day, and thousands of aircraft monthly. Tank production was merely one component of this industrial miracle, but it exemplified the disparity. Japanese tank crews facing Sherman tanks were confronting not just a better individual vehicle, but the entire weight of American industrial civilization. The Chai-Ha's vulnerability to 30-caliber armor-piercing rounds symbolized this disparity in miniature. The armor was as thick as Japanese industry could provide in quantity. The steel was as good as Japanese metallurgy could produce with available resources. The design was as effective as Japanese engineers could create within their constraints. But all of this was inadequate when measured against what American industry could produce without comparable constraints. Japanese engineers had designed better tanks by 1944. The Type 3 Shinu mounted a 75mm gun and had improved armor. The Type 4 Shi-2 had even better specifications, comparable in some respects to American medium tanks. But these designs existed primarily as prototypes or in tiny production runs. Only 166 Chi-Nu tanks were manufactured during the entire war. The Chi-2 existed in such small numbers that none saw combat. They were reserved for the defense of the Japanese home islands, held back for a final battle that never occurred. Japan could not produce these improved designs in meaningful numbers because doing so would have required resources the nation did not possess. Every ton of steel allocated to tank production meant less steel for aircraft, for naval construction, for coastal defense artillery. Every factory worker building tanks could not simultaneously build aircraft engines or assemble trucks. Japanese industrial capacity was finite, increasingly constrained, and utterly inadequate for the war the nation was fighting. The story of Marines discovering that rifle ammunition could penetrate Chai-Ha armor is not ultimately about ballistics or metallurgy, though those technical details matter. It is about the collision between belief and reality, between what Japan needed its tanks to be and what they actually were, between the confidence born of early victories and the devastating knowledge that came from facing an opponent with overwhelming material advantages. For Japanese tank crews, the progression was cruel in its clarity. They had trained with equipment they believed adequate. They had fought successfully in China, where that belief seemed confirmed. They had participated in the early Pacific victories, where Japanese forces achieved remarkable successes despite material limitations. Then they encountered American forces equipped not with the limited weapons of colonial garrisons or the improvised defenses of forces caught unprepared, but with the full production output of American industry. The realization came differently to different men. For some, it came at Saipan when 50-caliber machine gun rounds punched through Hago armor, revealing that even standard infantry weapons could defeat Japanese tanks. For others, it came on subsequent islands when Chi-Ha tanks that were supposed to be more capable proved equally vulnerable under the right conditions. For all of them, it came with the understanding that courage and skill could not compensate for industrial inadequacy. The Marines who captured Chi-Ha tanks on Tinian, who documented the penetrations and conducted the firing tests, were witnesses to a larger truth. They were measuring not just the thickness of steel plate, but the distance between Japanese and American military capability. 25 millimeters of armor that could not stop 30-caliber bullets at close range represented the absolute limit of what Japanese industry could provide. The ammunition that defeated that armor was standard issue, produced in quantities so vast that American forces never faced shortages. This disparity extended to every aspect of military capability. Japanese soldiers fought with rifles that were reliable but inferior in rate of fire to American semi-automatics. Japanese artillery was less numerous and less capable than American guns. Japanese logistics relied on human porters and limited motor transport, while American forces had trucks, jeeps, and abundant supplies delivered by a merchant fleet that Japanese submarines could not seriously threaten. At every level, from individual weapons to strategic mobility, American material advantages compounded. The Chi-Ha's vulnerability was symbolic of Japan's impossible strategic position. The nation had initiated war against an opponent whose industrial capacity exceeded Japanese production by factors of 10 or 20 to 1, depending on the category measured. No amount of tactical brilliance, no degree of individual courage, no cultural emphasis on fighting spirit could overcome that fundamental disadvantage. Japanese tank crews climbing into Chi-Ha tanks were not cowards for feeling fear when they understood their armor could not protect them. They were realists confronting an unbearable truth. After the war ended, some surviving Chi-Ha tanks were shipped to the United States for detailed examination at Aberdeen Proving Ground, joining the Hago tanks and other Japanese equipment already being studied there. American engineers measured, tested, and analyzed them with the thoroughness that characterized post-war technical intelligence efforts. Their reports confirmed what battlefield testing had indicated. Japanese armor design was competent within severe constraints, but inadequate for modern mechanized warfare against industrial opponents. These captured tanks eventually made their way to museums and military installations where they remain today as historical artifacts. Visitors can examine them, walk around them, see the cramped interiors and thin armor. The holes where American bullets penetrated have been preserved in some cases, physical evidence of the encounters that revealed Japanese armor's vulnerability. But the real legacy of the Chi-Ha story exists not in museums, but in the historical record, in the after-action reports and intelligence summaries and personal accounts that document what happened when Japanese armor faced American forces. It exists in the tactical doctrine changes that gave Marine infantry confidence to engage enemy armor with standard weapons. It exists in the production statistics that reveal the true scale of industrial disparity. It exists in the interrogation reports of captured Japanese tankers who expressed their shock at American material superiority. The Marines who fought on Tinian and Peleliu and Iwo Jima and Okinawa learned lessons that transcended any single battle. They learned that wars between industrial nations are won not primarily by tactical brilliance or individual valor, though both matter, but by industrial capacity and resource mobilization. They learned that equipment quality affects outcomes decisively, that better armor and better guns translate directly into casualties avoided and objectives achieved. They learned that the factories at home, the workers building tanks and trucks and weapons, were as important to victory as any combat unit in the field. For Japan, the Chi-Ha's inadequacy was part of a larger failure to understand the nature of modern industrial warfare. The nation's military leadership had studied European developments, had observed mechanized warfare, had understood theoretically the importance of armor and mobility, but they had not grasped, or had chosen to ignore, the industrial requirements for sustaining mechanized warfare against a peer opponent. They had designed tanks for the war they wanted to fight, in terrain they chose, against opponents they preferred, rather than for the war they would actually have to fight. The moment when marine testing confirmed that 30 caliber ammunition could penetrate Chiha armor under combat conditions was not the moment Japan lost the war. That outcome was determined by much larger factors, by strategic decisions made years earlier, by industrial capacities that could not be quickly changed, by geographic and resource realities that no amount of tactical skill could overcome. But it was a moment that crystallized the reality of Japan's position, that made visible in 25 millimeters of inadequate steel the impossible gap the nation faced. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.